So students, we are going to solve all the questions in very interesting way actually. So welcome to lecture 19th and we are into practice series now, but I will request you start all the sessions from lecture 1. If you have coming from lecture 1, then very good. Let's go for the question. See, I have taken the question. A ball is thrown vertically upward. You understand what is the meaning of vertically upward? See guys, this is also upward, this is also upward, this is also upward, this is also upward. Like vertically means straight upward. That is the meaning of vertically upward. With a speed of 19.6 meter per second. Every single data you focus, they have given speed, they have not given velocity. Okay, no problem. Because they have told us vertically upward, it means direction is not being changed, no doubt. It means it is straight line motion. It means it is 1D motion. That's why if the question will come suddenly in front of you, this is how you will judge the type of question. So this is 1D problem. Speed of 19.6 meter per second. You should also check the unit here. It is SI or not. Yes, this is SI unit. From the top of a tower. Okay. From the top of a tower. It means what? You have a tower and like this you can have some fancy towers and this is the road or something. Now from the top of the tower, ball is being thrown. So from here we are throwing the ball exactly upward, exactly straight. Okay, and then what will happen? They are saying from the top of tower returns to the earth in 6 seconds. It means what? This ball will go and then it will come back like this and it will touch the earth surface in, and the entire time, like this time here and then return time here. You can say this is t1 time and t2 time. This total time together it is given as 6 seconds. But see, if you don't know the concept the way I am going to explain, then how the student will solve? First, student will solve this part separately, and then student will solve this part separately, and then student will add the concept like 6 seconds. This is one way to solve the numerical, which is lengthiest way. Easiest and best way to solve this numerical is, what we have to do, we have to find the height of the tower. Okay, so you do one thing. Suppose this is the height of the tower, so consider this height from here to here is h. Okay, now from here we are throwing the ball upward. Okay, so that speed is given, that is 19.6 meter per second. Understand the example. 19.6 second is your speed, direction is upward. If I will consider this as velocity, and then if I consider that same speed, I will give you downward with 19.6 meter per second. Then speed will be same, but my velocity will become double. Correct? So this I will solve with the help of velocity. So see, h I am looking for. What is the given data? Downward velocity is given. Now see what I am saying, downward velocity I am saying, not the speed, because speed is just a magnitude. I am saying downward velocity. Okay, so I will use this formula. H is equal to, means speed is equal to, or height is equal to, height is equal to ut plus half gt square. This is my basic formula. Okay, this t and this t is time. But see here, in this formula one small change I will make. What is that change? This u I will consider as velocity and I will put this u as minus u. Why will I put this u as minus u? Because downward velocity I will consider negative. Now my point is, why I am considering this downward velocity negative? Why? Because vertical motion of the ball we took positive. Why I am taking vertical motion positive? Because the ball was thrown vertically upward in the beginning itself. So understand the logic here. If the ball will reach here and will become zero speed, then when the ball will come down, then exactly at the same level when ball will be directed downward, it will be having same magnitude. 19.6 was upward, then here also 19.6 will be downward. Okay, we are not considering the air friction on the way. We are not considering air friction, otherwise the speed will be different. But right now there is no data about air, so you don't consider air friction or any other kind of drag. Okay, so I hope it's clear. In the beginning this ball was going upward, now this ball will go downward, so I consider this velocity as negative velocity. So the height is going to be now see, fill the data. H is equal to minus 19.6 will be your velocity into, because see the total time is given at 6, from here to till here total time is given as 6. So same time, the entire time 6 I will take here. Why will I take same time? Does it feel like good? No. See, because if you have taken 19.6, it means already you are considering that upward direction positive, downward direction negative. We have done, that's why. Okay, I can take the entire time here. After that, plus half into g. Now g value we can take 9.8 meter per second square, of course, into the time 6 square. When you will calculate this, then your answer will come. Some answer will come here. You just text me in the comment box so that I can know you have enjoyed this numerical. Okay, now we'll move to the next numerical.